בסדר, שלום לכולם, אני אלכסון, זו פעם ראשונה שאני אנסה לתת הרצאה בעברית מאז 30 שנה, אז אני מתנצל מראש, ובאיזשהו שלב אני אצטרך לעבור לאנגלית, אני מתנצל עוד פעם. אני מאינטואיט, כמו שאני חושב שרוב האינטואיט זה חברה אמריקאית, מכובדת, ואם לא שמעתם עליה זה בגלל שהיא מתמקדת בעיקר בתחומים חשובים בארצות הברית, אני חושב בשנים האחרונות התחלנו להרחיב את הפעילות מחוץ לארצות הברית, והתחומים, שני התחומים העיקריים של החברה זה תוכנה להכנת המיסים, ותוכנה לחשבונאות לעסקים קטנים. ואני רואה מישהו מפרק שם, זה משהו בגלל של חשבונות אמרתי, אבל בעצם זה מה שאני מנסה להעביר בהרצאה שלי, שבשבילכם, בשבילנו כדאטה סיינטיסט, זה תחום מאוד עשיר ומאוד מעניין, עם הרבה בעיות מעניינות לא פשוטות, שיש להם גם פתרונות מעניינים. וכמובן אנחנו מקווים שתתלהבו מזה ותבואו לעבוד איתנו, יש לנו פה חבר'ה שעובדים בישראל, יש שני מצטים בישראל, נראה מייקל פה ובת שם ועוד חבר'ה שעובדים קבוצות כאלה, יאיר, אז כולנו נצטרכו לדבר איתכם. שמתי כמה תמונות, אני בעיקר אדבר על פרויקט אחד, ושמתי תמונות של אנשים שעבדו על הפרויקט. אתם כן, המרצה לקולנוע דיבר המון על הדומיין, אתם כן צריכים להבין משהו על חשבונאות בשביל להבין על מה אני אדבר. והנה גרסה של 2 דקות, פחות או יותר המטרה של ניהול חשבונות זה להבין מה הערך של החברה, ונכון להיום, או מה התוצאה של פעילות עסקית זו או אחרת, ודרך שעושים את זה, פחות או יותר רושמים טרנזקציות עסקיות ומחלקים אותם למה שנקרא חשבונות, accounts, וכל האקאונט של החברה הם קוראים checking accounts, ומה שבן אדם או מה שחשבונות עושה, הוא יוצר את הטרנזקציה העסקית והוא מסרק אותה לחשבון מסוים, זה פעולה של סיכון, ורוב הפעולות האלה עד זמן האחרון היו ידניות, זאת אומרת שבן אדם ישב ודקדק את הנתונים והכניס את זה אפשר לחשוב, זה מין כזה, והתוצאה הסופית שאפשר להמציא דוחות. זה כשלעצמו לא מלהיב במיוחד, אבל כשמנסים להפוך את זה, לעשות את זה באופן אוטומטי. אז אנחנו צריכים למצוא דרך איך ללמד את המחשב, לראות את הטרנזקציות שמגיעות אלינו מכל מיני מקומות, ולנחש מה הסוג של הטרנזקציה, איפה זה שייך. אז הנה, זה סקרינשוט של התוכנה, שבו בעל העסק אימפורטס טרנזקציות מהבנק, ומנסה לשים אותם לחשבון הנכון. עכשיו זו פעולה כמובן ידנית, מעצבנת, אף אחד לא רוצה לעשות את זה, והיה רצוי לעשות את זה באופן אוטומטי. עכשיו, מה הדברים שידועים בשלב הזה, מה הדאטה בעצם שאנחנו יכולים לראות? אז הנה בעמודה השמאלית, אתם רואים בערך מה הדאטה שמגיע מהבנק. יכול להיות שאתם ראיתם את זה אם אתם משתמשים באיזושהי תוכנה לניהול חשבון מהבנק. Somebody doesn't understand English? Go ahead. I'm sorry. Okay, so I switched to English because I feel actually more people will understand when I speak English than speaking. Thank you. So on the left you see the information as it comes to us from the bank. Some of it can be interpreted by a person, some is really hard to interpret. And on the right you see the names of the accounts. So accounts, as I said, those are categories. There are manual categories that are created by accountants or small business owners to categorize their transactions. And today we're talking just about expense transactions, so transactions that can import from the bank, for payment networks. And the point of this chart is basically to tell you, if you look at this, intelligent, well-educated people, you'll have a hard time figuring out what belongs where. And so, naturally, that's some form of indication of the signal that is present in this data. They give you some idea about the scale of the variability. So this turns out, if you don't see this little dots there on the screen, it's because something is wrong with your eyes, and you need to see the eye doctor immediately. But I actually didn't. It was a joke. You could watch. But so the information that is in those little dots there can appear. They may be the place where the transaction took place, maybe some reference numbers, maybe some trace of the payee name to whom you paid money. There may be some information about how you paid. You use your debit card, your credit card, you paid at the point of sale, etc. There are, of course, many types of errors in this data. This is not a clean data at all. So the tokens could be truncated, merged together. There are no definite delimiters. Many transactions are duplicate, and there are many reasons. So we could talk about this process that generates this data is not a very clean process. So there's some idea of the distribution. 300 million transactions. We could take a batch. It doesn't matter what is this selection. This is some kind of selection. 300 million transactions. So you will have 9 million unique descriptions. So, and 5 million of those appear just once. So more or less, you saw the semantic content of the description is not very rich, and there are very few examples taken as they are of how description relate to each other. If you look at the accounts, again, that's very important. I mentioned each company, in principle, can create accounts which are specific to this company. And why is that? Well, because part of the purpose of creating those accounts is really to understand how your business works. And small businesses seem to exhibit huge variation. And people use accounts that are intuitive for them. They buy a truck and they say, well, my Ford, that's my account. My, I don't know, Jane's truck, which is Jane's my partner, etc. So there's huge variation. There's like in this batch of 100 million accounts, approximately there were 1.5 million accounts that were related to vehicles. So it's kind of important to understand the scale of the problem. Let's talk about the transaction variability. Pick some transaction descriptions that belong to the same store. It's the same physical store, not the same network store, but same physical store. And I know because there is a store number in this particular description. So they all relate to the same Safeway store, and there are like about 300 ways it appears in the data. So clearly, this is true about other businesses, but they wouldn't have the store number and clear name that allows me to identify that it's the same one, but it gives the idea of the variability. And the reason for the, again, it's important to understand what's the process that creates this variability. The process is due to the complexity of the payment network through which the data is flowing. And so the initial information comes from some point of sale, and it goes through some gateways into the payment network, and it can cross different gateways, and obviously different transactions go to different payment networks, eventually reaching your bank, the consumer's bank, which doesn't at this point even know who is the merchant that actually initiated the transaction. And what we need to figure out, who is the merchant. And why do we need to figure out who's the merchant? Well, we need to figure it out because this is the best signal with respect to what kind of transaction this is. Of course, it would be ideal if we knew what exactly you bought. But that is, information is just not present in this description. We can talk about there are ways to approach the problem, but it is far away. So here's a kind of heat map of a selection, which is again to give you, I'm still trying to give you an impression of what kind of data, what is the scale, what's the nature of the data we're dealing with. And this is a heat map of transactions versus account, and this is the most used, this line, or this selection specifically, most common transactions, the most common account. Because if I took a random transaction account, it would be just black. Everything would be just black. And so the point here is that if you look at it, it seems that there are some patterns there. There are some regularities. It would be nice to figure out what those regularities are and maybe use those to automate the process of looking at transactions, finding the category for a particular company. So here I will walk you through the process that can be the intuitive idea. So here's the example of transaction that come from the bank, and there are some processes that are run inside the company to maybe augment this information with what we potentially know about this merchant, for some other merchants we just don't know anything, and they let them categorize, and there is maybe an attempt to figure out, based on information was known about the merchant, to figure out what specific account for this specific company, and I said this company specifically belonged to. And this is a process that results in a very low accuracy of prediction, and partly because of the nature of the data that I described. The signal is relatively low, and the attempt to recognize the merchant from descriptions, figure out business category, is difficult. So here's the intuition. The users, as they receive these transactions, they go and they actually manually assign them to their own accounts. And very kind of simple intuition says, well, could we use information that is provided by users that see transactions first time and may be projected towards use it for other users? And here's the first green column there, the green and yellow there, company ID, and the essentially names of the accounts they selected. And so you see that while the general categorization was business expense, you see some companies said, well, it's software, some companies said it's services. If you look through several choices for merchant that we've seen several times, you'll say, well, most of them said software, so maybe we could predict that this is software. To understand how often this can work, have another look at the data, how it works a focused way versus let's take some kind of sample. So here's again a sample that's selected from a single year of transactions. So in this sample there are 500 million transactions. 17 million of the PEs that were extracted through the processes I mentioned before by identifying traces of part of the description that refers to the merchant. Is about 17 million distinct PEs. They were put into 22 million different accounts. So each company has different accounts. I could use the intuition that if companies call a company the same name, maybe it means the same thing. And it sometimes means the same thing, but there will be 4 million of these unique names. And clearly what I wanted to point out is that there are companies, there are accounts that are named in the same way but mean different things. That is used for different purposes. There are accounts that are named differently, but used for the same purpose. So it's clearly the name signal is, while it is a signal, it's not a definitive signal. So this is one way to look at the data. The other way to look at the data is to look on the average distribution for a single campaign. So again, in this particular sample, if you take a company, there will be, let's say, 400 transactions, 90 of them will be with distinct fees, and the companies have put them into about 30 different accounts, while they had overall 60. So, because each company has unique chart of accounts, there is, a priori, there is no connection between accounts of different companies, whether, and so, if we just look at the single company level, we have a problem of we have more or less 90 examples, right? 90 examples they possibly have categorized. The new event can bring you one of the 17 million different payees. In the worst case, of course, in reality, this is not the case, because nobody deals really with 17 million different vendors. Can talk about what can be expected there, and you need to make a prediction. So, in the person before me said that the simplest model that possibly work, and that's what I think the company has been doing forever, more or less. If the company has seen a transaction like that before, best tool is categorize it in the same way. And that's a very accurate prediction. People with creatures of habits, we do again, same thing again and again. And unfortunately, because of the expectation of new transactions with new vendors, about 50% of transactions are with new vendors. So this model, this predictor, can, in the best case, do about 50% of accuracy, which is doing closely to that. So the other thing, again, I showed you before, you can build an expert system, analyzes the semantic content of the description, recognizes traces that describe the merchant, matches it to a real-world merchant, extracts business category, tries to match this business category to some description of the account, semantic description of the account, like using names or other description categories. And that is, despite heavy machinery that you have to put into this work, results in about 30% of accuracy. And of course, if they dealt with different transactions, the two methods dealt with different transactions, you could get pretty good accuracy of categorization, but there is an overlap, so together you probably get 60% of the accuracy. What it means, if you remember the first chart, I as a small business owner, brought my transactions from the bank, reported 300 transactions the first time I touched my accounts, and now I need to manually to essentially categorize over 100 of those and potentially create new accounts to deal with them. What's the kind of intuition that, what is it that we are trying to do? Really, we're trying to estimate or rank different accounts for a particular company by likelihood. Now, I can think of this, so this is a table that tells you that if I take a particular company, and I could essentially look at the likelihood of accounts with respect to this transaction, and use this as a ranking. So what is the problem with this direct approach? Give you approximate numbers of the scale that you would have to deal with that. So the overall, I said you had about 4 million, let's say 10 million different vendors, over 4 million different accounts. this is like 40 trillion cells in this table, and we have half billion examples to estimate those parameters. This is a non-starter, obviously. So somebody can say, well, that's maybe not, this direct approach is not so effective. Maybe we can decompose it in some fashion to reduce the parameters that we need to estimate. So here's an estimation. That's not a practical approach to do it, but here's an estimation of what we can achieve, is known as UV decomposition. Some of you definitely know what it is, but basically it says, well, instead of taking this big matrix, I'll decompose it as a product of two matrices. One is tall and skinny, and one is short and wide. And let's say they have the common dimension of D, and let's say what is a reasonable, this D actually is the, let's think of this as some kind of dimensionality reduction that carries signal from one domain to the other. So let's say if we estimate it as, let's say 10 is a reasonable compression factor, it's hard to expect you more. So you certainly will move from the, what did they calculate, 40 trillion cells. You'll move because to essentially sum times the common dimension. So it will be, what is it, 140 million, right? 14 million times 10, 140 million. Still, a very difficult, or very precise, essentially, estimation of 140 million parameters using 500 million examples that are not independent examples. Remember, about half can be expected to appear once in the set, so you reduce, you won't have enough examples to estimate the free parameters. So what is the conclusion? What is the intuition? The intuition is that you need to compress in some fashion the data that you collect so that you bring it to the size or scale that is possible to estimate with the scale of the data that is available. That's kind of the basic insight, and this is, it's translated into domain, in the domain language, is how it can be compressed. So it can be compressed using the idea that similar companies, so we assume that not, even though every business can have completely different accounting system serving the business, there are some similarities, because there are some processes that drive the accounting. They're shared processes. People want to optimize their business performance. They need to prepare for taxation, which provides some kind of common drivers for designing the systems. They need to manage the expenses of their cost of goods they purchase, the cost of services, etc. So if we were able to somehow group the accounts and transactions by similarity, companies would be able to compress the domain sufficiently so to be able to do a reasonable estimation of those three parameters and do some probabilistic prediction of account categories. Now, this is a very hard problem. If I ask which companies are similar, well, some people say there's similar business, similar size business, maybe similar age businesses, similar domains, similar industries, or which vendors are similar against similar business domain. Unfortunately, while it's not incorrect, collecting the signal or extracting the signal from the available data is very difficult. Now, I'm going to continue telling you that the problem is difficult, but I actually have somebody who did it much better than I. Inside the company, and most of those slides were shown first. Inside the company, everyone knows who is the person, the CEO of one of competitors of our companies, who tells exactly the same story. He says, well, we found out the differences between the ways businesses do their accounting is really, really big. He says, we're currently providing only models that learn from practices of individual businesses, which the initial story I told you, just look what the businesses before, repeat the same. They said the interesting part is maybe the last statement is that we could trust DataHack common definition. That basically you could trust that accounts are similar for different companies and that there's some way we could translate from the accounting practice of one company to the other. We could potentially provide a myriad of useful services. So at the time, this was published in March last year. At that time, we already actually had a working system that was doing exactly that. So I'll spend the rest of the telling you what exactly it does. So revisit the initial matrix that I described. Essentially shows the, let's say, looking at the column-wise, it shows the likelihood of this account with respect to different transactions. So if transaction T1, T2, TI occurs, what is the likelihood of this account for different transactions compared? And so one way to think about it, well, this is a very sparse matrix. This is a vectorized representation of this account with respect to different transactions we have seen so far. And if I look at the rows of this matrix, this is a vectorized representation of this transaction, of this vendor, with respect to accounts, to which it has been categorized in the past. Well, if we look at this data in this way, we actually can use standard ways of defining similarities in vector spaces, as we learned in school, and maybe clustering these entities just based on the data that we are receiving from millions of companies we currently serve. So, yeah, you can apply the last line says, yeah, you don't use it straightforward, like you can apply some normalization like TF-IDF normalization, so exclude vendors or lower the signal from vendors that appear in every possible account. This is fairly, so you can actually think of this, those who are familiar with this, think from, let's say, document classification. You could think of transactions as terms and documents as accounts. And you're using the same ideas to essentially represent, and you could use all other ideas from the same domain, like from the same, like embeddings, to essentially establish similarities between different accounts. Once you've done that, you can cluster accounts based on the similarity of transactions that end up in these accounts. You can cluster transactions based on the similarity on which accounts this transaction. So essentially, what you are able to do, you're able to determine semantic matching of accounts across companies independently of how they're called or what the company is doing. And the same is for vendors. You're able to determine which vendors play the same role with respect to accounts and practices. So what it enables you to do, it enables to compress the entire matrix to appropriate dimension. You could say use 1,000 by 1,000, which give you 1,000,000 cells. With 500 million transactions, you can do a very good estimation of 1,000,000 parameters. And in essence, what it allows you to do when the transaction comes in, you have a very good estimation for the cluster of accounts it should belong to, and you can map the particular transaction into transaction cluster, account cluster, and pre-clustered accounts for each company would be predicted based on their likelihood. I will skip, I'll skip the specific, here the Intuit walks through a specific example that explains how it is done for a particular transaction. The idea, this is maybe a chart that summarizes the overall performance of the overall performance resulting from this. It's a rich chart, again, if you can't see, it's a very small font. The idea here is that when a transaction of particular, we know belongs to a particular company occurs, how this predictor works, how is it spread among the accounts of the company, and more or less the confidence is shown as the red hue. And so what you see more or less is whenever we're confident in the prediction, whenever we're confident in the prediction, it is actually correct prediction. And whenever the data is insufficient, and clearly in many situations the data is not sufficient, just doesn't have a signal that allows to make a confident prediction, it is a lucky guess. Occasionally it's correct, but often it is not. And it's the same idea that look at the precision. So when you predict a particular, when you predict that it is a particular account, how often it is actually a correct prediction, and you can see this very similar picture. This is actually a. You can think of this as a histogram of precision recall over different accounts. So more or less, what it gives the intuition that gives you, it has most of the predictions fall in the right part of the chart. The last chart that I will show you is an important chart that evaluates the confidence, like whether the confidence that we predict is actually meaningful. And why is it important? So when we make a prediction, if you remember the use case, there is a person who relies on this prediction to maybe save them work, sitting in front of the computer, typing things, editing things. So it's quite important for this person to know whether the prediction is made with high confidence or not. Now, if we're able to correlate confidence with the accuracy, we know that actually we can use this as a proxy to give user the confidence in automated system. So, and as you see in this chart, indeed, most of as the confidence of prediction grows, the accuracy of prediction grows as well, and most of the predictions are made as higher. The fat dot there, the dot high confidence and high accuracy. That is a very quick look into one of the projects we're doing in the data science group. What the project like that enables is providing higher level services for people, like essentially providing missing accounts recommendation for the case when, for example, account cluster that is identified is not represented in this chart of accounts. It's a very difficult, difficult procedure for a small business to say, well, which accounts do I actually need? Most of the business owners rely on accountant help to design their chart of accounts. This automated system is capable of recommending missing accounts to small business owners. Accounts actually are not a flat hierarchy. It's not a flat list. It's a hierarchy. Very often it is hard to design this hierarchy for from the beginning. It's only part science, there's art, and again, this automated system is capable of recovering hierarchy of proper hierarchy of the accounts, essentially optimizing categorization, enables splitting of the accounts, another tedious act. What I hope you leave with is that the domain is rich with data. There are billions and billions of data events. They are noisy, as most of the data that you will have to deal with, but they offer a range of nice, interesting problems that can be solved and are being solved. We are actively solving them. Really hope that some of you come and help us do it better. And we have people standing upstairs. There's a table of Intuit. They'd be very happy talking to you. I'd be very happy talking to you. And that is what I had to say. I think I may have a minute or two for a few questions. No? I'm sorry. I will have multiple minutes for questions, but not with the microphone.
תודה רבה לאלכסה, ועכשיו תהיה הרצאה של דייב מאור מספרטיון. סליחה. אחרי תהיה הפסקה, ואחרי עוד שתי הרצאות יש ארוחת צהריים.